Hello everyone, I'm Vincent. So I'm here as an Eclipse and modeling expert at CS. And here to present you Eclipse modeling technologies propelling the new generation of space database editors, aka BestNG. So I'm also a technical lead on the BestNG project. First, I expose you a short history of the project, then the technical design behind the tool, how we use the developer tools to design the generic model used in the BestNG modeler, how we mapped the formats with this generic model, a few words about the expression editors, and finally, what's next, the future of BestNG. So, project history. Before BestNG was Best, so here's the link. Best means Beyond East. It's maintained for both CNES and ESA. It is in open source license with EPL. And it relies on a format file, which is called XIF. It's an XML-based file. And there's possibility to extend this format with extensions, especially the one we're interested in is the monitoring and control extensions, which brings in space-related concepts. It's based on quite old technologies. The ADA core dates from the 90s, so we wanted something more modern. So where does BEST fit in the space domain? There is data exchange between the satellite and the ground. And this data, this stream of bits, has to conform to a given structure. And this is what the space database model is for. It describes the structure of bytes that are exchanged. It may contain no space-related information, just fields and types, or it may contain additional space information, such as monitoring and so on, so that when a value goes wrong, the operation control is one. BEST modeler is aimed to modelize the space database model. There are other additional BEST tools which use both the data and the space database model. For example, for data generation, for data processing, and so on, and for data reading, post-processing, plenty of things. This is what the old BEST looks like. So we want something definitely more modern with higher capabilities. So what are the BestNG needs? We need to support bigger databases. The BEST was handling only 20 megabytes files, and we have databases with XTC files, for example, which are over 100 megabytes already. We also need a functional scope as large as BEST. BEST allows to model space database without space information and also with space information with XIF extensions. And we want both the aspects with the monitoring and control extensions, which we would be able to plug and unplug on demand. We also want to support several formats. We need to communicate with tools using the XIF format, the XTC format, which is used for international communications, and the CADS format, which is used mainly internally at CNES. We need better conceptions because there are pitfalls in BEST, like the expressions and references which were stored as strings, and that doesn't fit well in the model aware. So the iterative steps of BestNG. First, in May 2014, there was a preliminary study to study which technologies could support this kind of volumes. And we suggested, given the volumes, to have a distributed architecture and to use either EMF or XSD. So your guess, which one did I choose, EMF or XSD? So first, a quick question, who knows about EMF? Almost everyone. EMF is the Eclipse Modeling framework. So basically, if you do modeling with Eclipse, you do EMF. So the first BestNG implementation, I choose EMF, and it relied on the format which was MXIF for model XIF, which was quite close to the XIF with monitoring and control extensions, but more model-oriented. And also we choose the CDO technologies. So next, who knows about CDO? Less people. CDO is connected data objects. It's a technology that enables you to use EMF with models stored in a database. So if you mix distributed architecture and EMF, you have one technical solution, which is CDO. And of course, it's hosted at Eclipse. Only after that, CNES let us know about their intent to do multi-domain and multi-format concerns with the need to store at the same time XTC, CADs, and XIF models. And that's how we started BestNG. We had it coming. In fact, we knew that we anticipated this need. So when the call for offer came in, we already had the solution on the paper. And we said, OK, this is the solution we propose you. And it was accepted. The technical design. First, we have these multi-domain issues. So we have a first domain. What we call a domain is aspects of interest for a given industry. So the first domain is the bitstream structure seen as a tree. So that's the types and fields view of the bitstream. And this is what corresponds with the outbest to the XIF format without any extension. There's another layer, another domain which adds to this one, which is the space database with space-related concepts. These bitstream structures are packets, either telemetry packets sent to the satellite or telecommand received from the satellite. Sorry, the other way. Telemetry received from the satellite and telecommand sent to the satellite. And we are also monitoring a lot of other concepts, such as the WAV parameters, which are computed and so on. We also have format-specific information. For us, it's another domain layer, because in each of these formats, each have different scope, and there are some concepts which exist in one format, but not in the others. So we consider each one of them as additional information which adds to the core. And also we can have other mission-specific information. Like the XIF extension mechanism could be used to make something more adapted to a given mission. With BEST, we have also this need to have mission-specific attributes. For example, one can want a different documentation with specific attributes and so on. So we have to mix all these needs to store all these domains in the model, in the same model. So the solution, with a classic DSL approach, with EMF, you have one eCore file in which you store all your concepts. So that's not what we want, that's not modular at all. And you can't have multi-domain elements, which means an element is either instance of one class or another, but not the two at the same time. So this is a trouble for us because we want, for example, a telemetry packet to be instance of XTC telemetry packet and also CADs telemetry packet. So we can't have these multi-class aspects with a classic DSL approach. There is another paradigm in modelization which is called the profile approach, in which you have one base element with very little information, so file, and you implement domain concepts as stereotypes. And you store these stereotypes in a profile. Then you can apply several stereotypes, not one, on the same model element. So the stereotypes concatenate different information and complete each other to enrich the model element with additional information. So that's the way we want it. We want to move from a DSL classic approach to a domain-specific language approach to a profile approach with possibility to have different concepts enriching each other. So first we considered UML profiles because that's the OMG standard. So that's a good point to start with. But on the other hand, UML is not related at all to our domain. We would have complex mapping issues because UML works at a higher level than this low-level bitstream architecture. So we don't know what to map the concepts with UML. And that's very disturbing this will cause a lot of technical issues. Moreover, UML is very complex and very rich. So not only would it be difficult to map, but also the user will have plenty of properties which doesn't care about at all. For example, if we map a packet with a class, we would have additional properties and we have operations and so on which do not fit in our concept. So that would be a real nuisance to the end user. So that's the reason why we don't want UML for modeling the space database. Also, the UML implementation violates some of the EMF good practices because it has quite a old history. There are historical choices which are not good. And for example, some modeling technologies might not work optimally. And if you use CDO, you can only use the legacy mode with CDO. You can't use the normal mode with CDO and UML. So that's not a really good point for UML. And it's not customizable. We have additional concepts that we want to add to our profiles and so on. Can't do it with UML because it's the standard. You can't change the standard. Another approach we considered was EMF profiles. EMF profiles allow you to apply stereotypes on any model element. Here's the URL. So what's this URL? In fact, there was a nicer URL, but now it's a dead link. So this is the complete URL. And there were reasons for that, which I'll explain. There has been conferences about EMF profiles in 2011, 2012. So we have documentation about it. We have articles, and that's a nice thing. But it's not reliable, and it's definitely dead. It never left Eclipse Labs. There is no activity at all since 2013. And there has been 3 contributors at grand total. So definitely, it's not something that we want to rely on. Plus, it does the meta-level lifting by inheritance trick. That's a bit too technical to explain. But basically, it's something that will definitely cause problem with CDO, just the same way as UML causes problem with CDO. So we choose to implement our own profile solution. For the base meta model, we adopted the KISS approach. Keep it simple, stupid. So you only have the basic concepts which are not domain specific, which can adapt to any domain. We have a data which can be named, which can have children. That's all. Nothing else. We implement all our domain concepts as stereotypes in profiles. And then our format specificities are just additional domain layers, so there are also profiles. We respect all the EMF good practices. We do not do strange meta-level inheriting by inheritance or things that will cause problem with EMF technologies. And we can patch all we want. If we want to customize the profile concept, we can. By the way, we shamelessly mimic all that is good in UML because there are a lot of good things, especially the process in UML, and we definitely don't want to reinvent everything. So that's pure algorithmy, so we can reuse it without any problem. There's no license issues on algorithmy, at least in France. For multi-format issues, we have different formats. Each of these formats have specific classes with their own properties. So we have different properties, different classes, and we have similar concepts in this format. So we want to map these formats, these concepts, with the domain-specific properties. So for one model element, we want 2 faces. So I mean 2 faces. So we want to have a model element to have the XTCE face and at the same time the XIF face and the CADS face. So we want to look at model element and say, OK, I see this way or this other way. And the correspondences are not obvious. They are not one-to-one correspondences. They are complex, the correspondences. The formats have different logics. For example, the XTC formats uses composition and inheritance between packets. That's why packets looks like classes. Whereas the XIF format uses only composition. There's no inheritance for packets. So the mapping is not obvious. The multi-format solution we adopted, we rely simply on the what's going on? We rely on the EMF Facet library. So here's the link. It's stored at Eclipse. And we use the facets from EMF Facets to map with DSL elements, with DSL classes. Then these classes have derived attributes, derived properties, which are implemented with queries, and these queries are implemented in Java. We can also implement in other languages, but Java was the easy choice for us. So here is a short demo. So that's a CADS file. And in my CADS file, I got a telemetry parameter, which is named GNAAM-CCSH flag, with a parameter plus ID, which is 118. I open my model with the BestNG editor. So the model is interpreted on the fly, and domain concepts are constructed. So there I have TM parameter, which is not a CADS concept, but really a domain-specific concept with a space SMC. I have my plus information, 118, not in the CADS format, but only with the domain concept stereotypes. I activate the XIF facets to have the XIF point of view. So then I refresh my properties view, and the XIF facets will compute on the fly derived XIF properties. So here I can see parameter properties, which is a XIF class, not stored in my model. And I have telemetered parameter properties, which tell me it's a telemetry parameter. And there the plus identifier in the XIF format. Just the same, I can export it. So I simply persist it in the XTC format. And just the same way that the XIF facet show me the XIF point of view, the XTC facet will persist it with the XTC point of view. So when I open my model with a file editor, I've got a perfectly well-formed XTC file with XTC properties and not the stereotypes which I have in my model. And there I can find my hash flag with plus ID, which is here in hexa, because that's the way XTC presents it. So that allows me to switch from one format to another without any drawback. All the derived information are computed on the fly. How we design the generic model? So first, what's the generic model? Here you have the formats that we want to support currently in BestNG. So there's CADS, XTCE, and XIF with eventually monitoring and control extensions. Here are all the profiles and facets which are stored in the BestNG. So for each of these formats, I have profiles which store format-specific information, which are not in the other formats, for which there is no overlap, and facets which rely on inner layers to compute derived information. These are based on the space monitoring and control profile, which stores space-related information, space concepts only. Itself is based on the structured data profile, which stores the bitstream structure as a tree with types and fields. And all these profiles plug on the generic model core, which contains only my base model elements. There's also another profile here, generic attributes, which we use to store other specific information, which is not tightly related to our domains. For example, we have a description, documentation, nature unit, which may be used in other domains for FNVs of address today. And what we call the generic core with the CNES is these profiles without the domain-specific aspects. So it's generic in a sense that it doesn't depend on a given format. It's all the concepts we need to express for the space database core to go from one format to another. It's completely dedicated to the space domain. What is truly generic on a domain which is domain agnostic is only the generic model core. So here is the profile editor. So that's developer tooling for constructing these profiles. So here I open a diagram in my profile, in the space MC profile, and there I've got stereotypes. It pretty much looks like a Nicore diagram with Nicore tools. These stereotypes, I can rename them, I can draw them around, and so on. I can also add in the diagram another stereotype which is already registered in my profile. So here I have the Boolean MC expression stereotype, which allows me to use Boolean expressions. I can draw references, I have inheritance, and so on. So that's pretty much like an ECOR diagram, except I have additional concepts, like I can use constraint assignments to tell, okay, these stereotypes applies only in certain conditions. I also have specific actions to add facet annotations or to create the facet, to then open it in the facet editor and edit it. So the facet I created automatically is linked with this annotation to the stereotype. When my profile is ready, I right-click and I can generate a new version of the profile. So I generate a new definition, which will be the ECOR I can use to really create new domain elements. So this profile editor provides validation. We can implement validation rules with methodology and anti-patterns we've discovered so far. We have useful decorations and actions to work with facets and so on. And we can also use the Axelo query view, which I didn't show, but which allows us to do analysis to see, okay, this stereotype is linked to another stereotypes to analyze the impact when you update something. All this developer tool is made with Eclipse Sirius, which is great technology. You can look at, go and ask the guys at Uber's booth about Eclipse Sirius. They'll be glad to tell you. And it's really great if you want to develop diagrams fast and easy. The developer tooling is not everything. We also need a lot of expertise. We need modeling expertise to not create anti-patterns, but also domain expertise. The CNES and the development team are both specialized in the domain, and we have numerous meetings together to define on one hand what makes sense in the generic model, what we want to be able to modelize, but also what is the best usage. For example, nature and unit can be stored on a feed or on its types. We choose it to store only in the physical type in or import and export strategy. But in the generic model, you can store on different locations. So how we map the formats. For reminder, here are the formats, and these contains information in profiles, and the facets rely on the inner layers. So first, we have the DSL, which is an XSD or ECOR file, which we import in a profile. So the mapping is very simple. It's a one-to-one mapping. One class equals one stereotype. When you have these stereotypes, we extend them. We make them extend the correct base element, depending on the fact whether they have a name or whether it can contain children. Then we add facets, which apply on the generic model to compute the derived information. We move every derived information in these stereotypes to the facets, so that they are not autonomous, that they do not contain redundant information, and that they take the information from the generic model. Then we simply get rid of the syntactic trigger. What I call syntactic trigger is, for example, the tags in the formats, which are list of something, which do not bring any relevant semantic information. So we replace them by facet references. And finally, there is always a Java glue code to implement the import and export specificities. So the expression editor, just a few words about it. Here is an editor. We have a secondary plus with a Boolean expression, which is an existence condition. And we can edit it. We have a textual editor for this condition. And there we have auto-completion. We have references to some elements. We can reference another element in the tree. We can use different operators and so on. We can have references to the enumeration literals. And then we have also validation on the fly. So when my expression isn't correct, here I see the error. And I can use path, relative or absolute path, to navigate in the tree structure. When my expression is ready, I finish, I validate, and voila, the model is updated with a new expression. So this expression editor is made with Xtext, which is great technology. Xtext handles both the grammar and the semantic, which means it handles the grammar, which are the correct syntax, and the semantic because there's an actual model with references to model elements behind this grammar, behind the expression. So what we store is not just the string, but really the model. We work on a model subset. So here's a simple trick. We create a virtual resource because Xtext is intended to work on a complete resource. And we have tooling for retrieving the context to know when we write a relative expression, which element we're in. We have different grammars which inherit from each other. There's not one but 3 grammars. The generic expressions contains only the core operators and types. We have structured data expressions which allow us to do with the structured data to navigate in the tree with paths, relative and absolutes. We also have the space MC expressions which take advantage of the fact that we know when we have a packet that a parameter appears only once. So we do not need, in the space concepts, to make the whole relative path to a given parameter. We needed to reference it by its name. So that was done in the editor. Also, we have additional specific grammars with Xtext, which are used mainly for mapping, for transformation, and when an element cannot be translated to these generic grammars. These grammars are related to profiles. So we wanted to have a weak coupling between profiles and grammars to facilitate maintainability. So we get rid of all dependencies from profile to grammar by referencing interface and not the grammar root element. And we add stereotype constraints, which tells, okay, when I want to express something, when I want here to express the existence condition, I can use a Boolean expression with this grammar ID. And the link is performed only with the ID. On the other hand, the grammar should reference stereotypes. And here, instead of referencing the stereotype classes, which are not even generated, we reference the base element, and we use keywords in annotations to tell, okay, I can reference these kind of elements. And the services work on these keywords to know which relation to navigate to find the next possible elements or which element to reference. So this keyword mechanism allows us to compute, for example, the tree structure and to navigate in the tree structure or to reference the tree parameter. So what's next? We need a real HMI. There was minimal HMI effort in this prototype because it's part of a separate call for offer. We had a few experiments with JavaFX and Eclipse 4 with lazy loading because we can exploit the fact that on one hand, we can load only the elements we want to visualize, but also we do not need to load the whole model element, but only one aspect at a time. For example, if we want to display the list of telemetry parameters, you do not need to load their description and so on. You only need to load the fact that there are parameters stereotypes and get their base element. So you load only the aspects of the element you're interested in. And that's where you can have very performance killer. A better name because the BestNG stands for Best New Generation. Best is the old tool, which means beyond East. And East is enhanced ADA subset. So this has nothing to do neither with what BestNG does, nor with the technologies used. This has only to do with the project history. So it will be probably rebranded Disco, but we still have to rebrand everything. And we also want to renew the whole space database management suite based on BestNG with modern Eclipse Modeling technologies to perform a lot of tasks that we are currently performed with additional tools which are outdated. As a conclusion, this allowed us to make different vision, to have different aspects depending on the formats on the same model. and to represent different domains to merge all this domain information together in one model. So we can store extensor-specific information and CAD-specific information at the same time in one model. It can represent any domain. So not only space, but if you develop additional profiles, you can represent other domain of interest, and any domain can be represented with this approach. We had good performances. The XTC files which are 100 megabytes, we managed to import them and to export them, display them in reasonable time. And where domain expertise is required to model the profiles. The use of Eclipse modeling technologies was a really great asset. It enables us to do a lot of things, and it opened a lot of doors for future developments. Transformation is always a tedious task, but the good point behind it is that, on the other hand, maintenance should be reduced. In fact, it costs us less to update the profile, whether for an upgraded transformation dedicated tool. We did the exercise because we had to upgrade a transformation, and this was more efficient by updating the profile. So do not hesitate to evaluate the session. Thank you for listening. If you want to contact me, you have my visit card here, and feel free to ask any question.
You said you have to choose between EMF and XSD. Could you explain why you make EMF choose?
For being, in fact, in the study, my colleague said that both could support the architecture. The point was that with EMF, I had plenty of other technologies which really was an asset. So the use of EMF enables me to have other frameworks, such as comparison frameworks. There's a need for diff and merge of models, and we'll have a study for diff merge on models with a CAD format, and we can do the same on the BestNG format. So that's really the advantage of having a whole ecosystem coming with the technology, bringing additional technologies and bringing additional assets and additional functionalities at the end.
On the other hand, you can create EMF models from schema.
Yes, but I have to, in fact, when you create an XSD schema, you think it the data way. We have a data-oriented thing, which is different from this model-oriented modelization. You have two kinds of modelization. For example, that's the syntactic sugar with the list of, which brings no information. I mean, it's only meant to group things for an easier view. So it's meant for a file view of the model. And given the format we have to handle, we can't rely on the file view of a model. We have to have the model stored in a database and modern views for accessing this. So that's not the approach we wanted to use.
What is your feedback about using CDO?
So far, so good.
Bigger models and stuff like that?
Yeah, we were able to have good performances with CDO. CDO, I started investing in it. I started looking at it at the early hours, and it had great advances. So now I think CDO is really mature to store big models. There's no main issues with it. You have to respect some rules in your model, so you have to respect the good practices, which is why I said, okay, you cannot do meta-level lifting by inheritance, which is your DSL eCore inherits directly from an eCore class for a class of the MOF, and that would cause problem with CDO. So as soon as you respect this set of EMF good practices, you have no problem with CDO, and CDO is really leverage your tools, enable you to do a lot of good things. So you can do peer programming. You can share your models, and you can work at the same time on the same model, which you can obviously not do with a file approach. So thank you.